welcome to Chemistry with Miss E. Moving right along, we've got isotopes, alright? So I did make a video on ions. If you're looking for that, go find that video titled Ions, but we're going to look at isotopes here. And this is just a quick review, okay? So I want you to make sure you understand this topic. If you change the number of protons, you're going to get yourself a new element, okay? Not what's happening here, but just something to know. If you change the number of neutrons, then you are getting an isotope. That means the mass is changing, and that's when you get this lovely isotope, okay? Now, if you change the number of electrons, then you get your ion, okay, which was for another video. But today we're going to focus on, in this one, isotopes, all right? So let's go over isotope notation, okay? We've got two ways that an isotope could be like thrown at you or kind of written, if that makes sense, in the textbook or on homework or papers or tests. You have two ways. The first one is an X, so whatever element you're working with, the mass goes on top and the atomic number goes on the bottom. This is very, very important to keep in mind because this is opposite of the periodic table. For example, the periodic table gives you the mass on the bottom, mass on the top for isotopes, mass on the bottom, atomic number on the top. For isotopes, it's mass on the top, atomic number on the bottom. So just be very, very, very cautious, very careful of that. Another way they could give it to you is they put the element's name or symbol, and then they say the mass, okay, so a number. Let me give you an example of what this looks like using an actual element. So for example, I'm going to use boron. Boron is a B, and let's say there's a boron isotope that has a mass of 13 and the atomic number 5 on the bottom, okay, so this is what it would look like. If they wrote it in this format, then you would say boron 13, okay, because that's the mass number, all right? They also could have just put B13, okay? So three ways, technically two ways, but three different ways that an isotope could be written and formatted to have you solve from. One thing I really want to mention before we get into some practice problems is that the mass for an isotope will not always, in fact, majority of the time it won't. It is not going to match the mass that is on the periodic table. For example, boron here. Boron on the periodic table has a mass of 11, if you were to round that to the nearest whole number. Is 11 13? No, right? And so that's how I know that I'm working with an isotope, because the number of neutrons have changed because the mass number has changed. Are you following? Getting the hang of it? Now sometimes they might throw a tricky one, like a trick question your way, and it will match the periodic table mass, and that's okay. Just do the steps as normal. But again, the point of an isotope is that the mass is going to be different from the periodic table, because in nature, on planet Earth, you do have isotopes that exist for all of these elements, okay? The element is actually a combination of different isotopes with different percents that they make up of that element that exists on planet Earth, okay? The most stable isotope that exists for that element is the one you're going to see on the periodic table. We'll get into that in another video of average atomic mass calculations, but just something to keep in mind, okay? So do not use the periodic table mass. You need to use the mass that they specifically give you or ask for in the isotope notation, okay? So let's do some practice problems here. On the left-hand side, I gave you different isotopes. Then we are going to figure out the number of protons, neutrons, and electrons for each of these isotopes, okay? And I'll walk through the steps with you. We're going to start with boron 13, okay? Again, boron is the element name, right? And 13 is the mass. Remember, this is the mass. It wouldn't make sense if they told me the atomic number, because the atomic number, the number of protons for boron, will never change, right? Boron is element 5, okay? Nobody else in the periodic table can be element 5. Boron is the only one that has 5 protons, so that's not changing. But we are changing the number of neutrons, which is changing the mass number, okay? So boron 13. So, as I mentioned, boron on the periodic table also has an atomic number of 5, so it has 5 protons, okay? How many neutrons does it have? Let's figure this out. If the mass is 13, right, and remember the mass is always equal to the sum of protons plus neutrons, right? So if the mass is 13, then, and my protons were 5, then how many neutrons do I have, right? We've got your 13 minus 5, and so that's going to give us 8 neutrons, okay? So 8 neutrons here. And that's different from the periodic table, right? The periodic table version of boron, the most abundant isotope that exists for boron, would be 11 minus 5, okay? So it'd be a different number of neutrons, but this is okay. These are isotopes. That's what they're supposed to do. Number of electrons, there's no charge on this boron element. There's no ion charge of a +2, +3, -3, -2. There's nothing like that. So that means the number of electrons equals the number of protons, which will be 5, okay? All right, let's move to the next one. We have U, which stands for uranium, 23792. Now again, the 92 is the atomic number. That tells me the number of protons, so that is 92. And I'm going to go ahead and fill in my number of electrons because again, there's no charge here on this uranium. If there were, it would be listed in the top right-hand exponent corner, okay? There's nothing there, so that means it's a neutral atom, and so it's going to be 92 electrons as well. How do I figure out the number of neutrons, right? We take our mass, and we're going to subtract, right, the atomic number. So 237, right, minus 92, I get 145 neutrons, okay? So that is the amount of neutrons for this uranium isotope. Continuing on, we have carbon-14. Again, this is the mass, right? And so I'm going to go to the periodic table first. We need to figure out how many protons it has. Carbon has an atomic number of 6. So that means it has 6 protons and again 6 electrons because it's neutral. It's a neutral atom. All right, it's an isotope. And the number of neutrons is going to change, right? Because the mass is 14. It has 6 protons, so 14, right, minus 6, we're going to get that 8 neutron count, okay? Again, different from the periodic table mass. Carbon on the periodic table would be 12 minus 6 to give us 6 neutrons, okay? And it's different. Different number of neutrons, versions of carbon, isotopes, okay? Try this one on your own. Pause it real quick, see what you come up with, okay? All right, coming back, hopefully you tried it, you feel somewhat good about it. Let's see how you did. We've got lithium 8 and 3. Again, remember that 8 is the mass, okay? That is telling us the mass of lithium here. It's an isotope version of it. And this is the atomic number, okay? So this means the number of protons is 3, right? Lithium always and forever will have 3 protons. There's no charge here on this lithium, so that means it also has 3 electrons, all right? And now if I do my neutrons, and I'm going to take the mass, and I'm going to subtract the atomic number of 3, which is the protons, 8 minus 3 is going to give me my 5 neutrons, okay? Let's just say for the fun of it that you were given lithium plus 1, 8, 3, right? This is a very difficult question. This has ion, isotope, all in one problem, okay? Number of protons would still be 3. My number of electrons, though, would no longer be 3 because now I have a plus 1 charge. Remember, a plus 1 charge means that this element lost an electron, so it would actually have 2 electrons, and the neutrons would still be 8 minus 3 to give me my 5, all right? What should you watch next if you are continuing on in this series? We're going to do average atomic mass calculations, dealing with isotopes and what all of that means. See you on the next one.